And there's basically three main reasons why we're deficient in minerals. One, our foods are now more nutrient depleted. Two, people just aren't selecting the right foods to hit optimal intakes of all minerals. And then three is the chronic disease states.
Welcome to the Seamland podcast. I'm your host Seamland, and today we talk with Dr. James DiNicolantonio. Dr. James and I wrote a new book called The Mineral Fix, which talks about how to optimize your mineral intake for energy, longevity, sleep, immunity, and so much more. This book is the bomb. It's the most in-depth book about minerals I've seen, and it contains up to 700 pages and over 4,500 references. It's perfect for anyone who wants to eat a diet that covers all your mineral requirements and improve their health. You can get the Mineral Fix from Amazon. James, welcome back to the show.
Seam, thanks for having me.
Yeah, you're almost a regular on the podcast already, and for a reason. We have another book coming out.
Yes, indeed.
Yeah, and this one is going to be focused on minerals and why would we why write a book about minerals, and why worry about your mineral intake in the first place?
Yeah, I'm excited, really excited about this book because it was probably the biggest request that I got from my followers is after I was publishing a lot of magnesium, they really wanted a book on all the minerals. So I think you and I coming together was perfect. You know, you're really good at piecing together a lot of the science, and it's something I've published a lot on. So, and it's a huge issue, and we can get into the reasons why, but I think people are going to be pretty blown away by this book because it's just so evidence-based, almost 5,000 references, over 750 pages. So it's just, it's a beast.
Yeah, I agree. And it's a pretty big book and very thorough. At the same time, I believe we make it also pretty simple and kind of easier to comprehend. It does go into very scientific detail, but at the same time, it also maintains this a user-friendly kind of aspect to it.
Right. I think we did a good job in regards to a lot of the times, if there's something pretty in-depth, we create figures to sort of simplify it.
Maybe let's start with what is the importance of the minerals in the human body in the first place, and how does it affect, let's say, just our overall health?
Right. So there's 17 essential minerals and 5 possibly essential. And so the 17 essential are broken down into 7 macro minerals and 10 trace. And they do all different types of things, but essentially their primary function is cofactors. So these enzymes in our bodies can work. But I mean, that's just the bare minimum in regards to what minerals do. They literally are the shields for oxidative stress because they make up our antioxidant enzymes. They help us produce and activate ATP, help us produce DNA, protein. So literally every function in the body in some way is dependent on minerals. So if you're not getting enough, a lot of people realize if you're eating badly, if you're eating sugar or you're eating seed oils, that's bad for your health. But if you're not getting optimal intakes of minerals, that can also be just as damaging.
Yeah, that is a pretty a profound realization. A lot of people let's hope that they have, and I definitely kind of understood a lot more about these how deep it actually goes with the minerals. They go straight into just the pure energy production. You need magnesium for energy production and some other minerals to say break down carbohydrates and fats and produce protein or synthesize protein. So yeah, it's a very kind of different viewpoint on nutrition itself, and it's a very kind of paradigm shifting, I believe.
Right. We go into, and we have figures on why minerals help through glycolysis, how we produce ATP by breaking down glucose, how minerals are important for feeding pyruvate and acetyl-CoA right into the Krebs cycle, and then how even into the electron transport chain, we show all the minerals that are actually contained in the complexes that help us form ATP. So we try to take both a real world approach to this, but then also kind of zone in on the mitochondria too, to show you how important minerals are. Even from the fact of even protecting the mitochondria, things like manganese superoxide, which is actually in the mitochondria to protect it from oxidizing.
Yeah. And one like really scary statistic that we talk about in the book is that how prevalent, let's say, these mineral deficiencies actually are. So like I believe it's like 1 out of 3 people in the US have like up to 10 mineral deficiencies of the common essential minerals.
Right. Yep, exactly. So and those 10 would be potassium, magnesium, calcium, chromium, copper, zinc, iron, molybdenum, and boron. I think I hit all 10. And essentially, it's due to a plethora of reasons. And there's basically 3 main reasons why we're deficient in minerals. 1, our foods are now more nutrient depleted. 2, people just aren't selecting the right foods to hit optimal intakes of all minerals. And then 3 is the chronic disease states. So the damage to the gastrointestinal tract, so we're not absorbing minerals well. The high inflammation is taxing and increasing the burn rate of minerals. Kidney damage is increasing the excretion of minerals. High insulin levels are spitting minerals out in the urine. So those 3 key factors are why so many of us are depleted in so many minerals.
Yeah, and like there's the thing that your body you don't develop these let's say mineral deficiencies overnight, and at the same time the consequences of having like a suboptimal magnesium status or suboptimal chromium status isn't also gonna affect you in like even within the months. It's gonna take like years and maybe like you have several decades where you actually get some serious sickness because of this chronic low intake and the deficiency of a particular mineral. And like that's where like things like metabolic syndrome come from, diabetes, insulin resistance, weight gain, and those sort of things.
Right. Yeah, exactly. And then there's like a really quick, there's a where you hit in your body where you have so much damage that you rapidly then become depleted in your minerals. So whether it's you hit a point where your intestinal tract is so damaged, or you start spilling albumin. Once you start spilling albumin out in the urine, a lot of minerals are actually attached to albumin, like copper, zinc, even some magnesium. So if you test for microalbuminuria, which is common in diabetics, it's guaranteed that they're actually losing minerals through the loss of that. And so once you start breaking down the barriers in your body, whether it be in the stomach or the kidneys, then essentially you can't even hold on to the minerals that you're either consuming or have in your body.
Yeah, it is a pretty delicate, let's say, balance the way your body deals or like stores those minerals. It's relatively easy to like lose them, and let's say if you're already in a disease state, your let's say poor kidney function, as well as like poor gut condition, like maybe malabsorption conditions like celiacs or like intestinal permeability, then you're also like at a disadvantage in getting those minerals from your food because you're like at a reduced absorption rate.
Right. And then you brought up a key point, balance. Balance of the minerals is also important. So not just absolute amounts, but also keeping them in balance. So there's 3 main minerals that there's pretty good data on what the balances should be. So for example, zinc and copper should be around a 20-to-1 ratio for zinc to copper. Sodium, potassium really should be about a 1-to-1 ratio. For potassium to sodium, you could go a little bit higher than 1-to-1, even 2-to-1. And then magnesium and calcium have to be balanced as well, because magnesium helps calcium from essentially becoming overloaded in the cell. So, and really the best ratio for calcium to magnesium is probably around 2 to 2.5 to 1. So got to keep those minerals in balance to have optimal health.
Yeah. You mentioned, that the minerals are like needed for the antioxidant defenses and like just your body's resilience. So how do they, let's say, affect your strength of your immune system and like the antioxidant defenses?
Right. So a lot of people kind of think of antioxidants just being vitamins, like vitamin C or vitamin E. But really, the first antioxidants in any living organism was really minerals. So you had essentially like blue-green algae, 3 billion years ago, producing the oxygen and creating all this oxidative stress. And they utilized selenium and iodine as their first antioxidants. And in humans, we actually utilize those pretty similarly. So iodine can bind to polyunsaturated fats directly, protecting them from oxidative stress. And then the formation of thyroid hormones also act as antioxidants. Even reverse T3 acts as antioxidants. So the antioxidant effects of our thyroid hormones are like 100 times what vitamin C and glutathione and vitamin E is. And you need minerals to form your thyroid hormones, particularly iodine, but also selenium. So not only from that aspect of directly inhibiting polyunsaturated fats from oxidizing, which minerals are important for, particularly, like I said, iodine, but you also need them as cofactors for your own antioxidant enzymes. So I had sort of mentioned manganese superoxide dismutase, which is in the mitochondria, protecting the mitochondria from oxidative stress, which you get reactive oxygen species just going through the electron transport chain. So you need to have that manganese superoxide in there, but you also have glutathione in there too. And the levels of glutathione are directly dependent on your selenium status, your magnesium status, and then how we handle other oxidative stress. Like superoxide anions are produced from NADPH oxidase, and most chronic diseases have an increase in NADPH oxidase and a production of those superoxide anions. Now, those are harmful because they can combine with nitric oxide and form the harmful peroxynitrite. So what's interesting though is you have superoxide dismutase that can sort of get rid of and neutralize the superoxide anion, and that depends on copper and zinc. And so if you're low in copper and zinc, you can't neutralize the superoxide. It combines with nitric oxide, reducing your nitric oxide levels, increasing blood pressure, leading to atherosclerosis and heart disease. And then you form the toxic peroxynitrite. So it goes to show you how just having a low mineral status can lead to high inflammation.
Yeah, that's a really great example of that, and a very important one as well. That, yeah, like like mammals and animals that breathe oxygen, they're just the aspect of breathing itself creates this oxidative stress and reactive oxygen species a little bit, and like digesting food does it, and not to mention all the like environmental pollutants and stressors that we're already exposed at a higher rate. So all those things just increase the kind of burden on our antioxidant defense systems, and if we're like deficient in some particular minerals and nutrients, then you're at like a huge, you're very vulnerable to just all the damage that we're bombarded by from the outside world. And like that is where like disease also comes from, like your body becomes overwhelmed by this constant bombardment.
Right, exactly. So even the cytokine storm, where there's a ton of damage to the proteins in the lungs, how we actually heal oxidized proteins like methionine and cysteine is through these complexes that depend on minerals. So thioredoxin reductase is one of them that requires selenium to help actually sort of take care of the oxidized methionines and amino acids in the body. So if you want to heal from oxidative stress and protect and have your shields up from oxidative stress, you got to have your mineral status up.
Yeah, that's for sure. And you mentioned like copper and zinc are one of the main components of the superoxide dismutase system.
Right. So there's three different types of superoxide dismutase. The two in the cytosol and in the blood are copper or zinc superoxide dismutase, and then the mitochondria has the manganese superoxide dismutase.
Right. Is there any particular how would, let's say, having a high optimal level of those minerals in your blood affect the antioxidant defense system versus just being nourished or like eating them? Like, is there a difference? Could you still have like this high defense system, like for example, if you're fasting, but you have like prior to that fasting, you have like an optimal level of those minerals, would you still be protected, or would it be that you need to kind of constantly on a regular basis eat those nutrients in order to have those defenses optimized?
Well, that's kind of the real crux of our book, is that the RDAs don't get you to the optimal levels of your antioxidant defenses, because that's what they're not based on those type of measurements. They're essentially based on balance studies and making sure you're not actually deficient, or at least 98 to 99% of the population isn't deficient. But if you're looking at the reduction in antioxidant enzyme functions, or any enzyme that depends on a mineral, that's kind of how you want to look at optimal intake levels. And so if you were to actually look at the enzymes that are dependent on, let's say, vitamin C, for example, you need to consume at least like 120 to 150 milligrams of vitamin C to make sure those enzymes are actually highly optimized, which is completely different than the 6 to 8 milligrams needed to prevent scurvy, right? So you have this, 10 to 1,000, up to potentially 1,000-fold difference in preventing deficiency and optimal intake. So I'll give you another example would be magnesium. You only need like 150 to 180 to prevent deficiency, but the optimal intakes are more around the 600 milligram level. So it just goes to show you that if you're looking at antioxidant enzyme defenses, it's much higher than just the RDAs.
Yeah, yeah, and another example of that would be like chromium. So like the minimal adequate intake for chromium is like suggested to be maybe like 33 micrograms, but optimally, like if you're, let's say, insulin resistant, then you need like 200 or more even to kind of combat that insulin resistance and help your blood sugar management to work properly.
Yeah, that one's a really good example. You're right, because 30 micrograms is the RDA for essentially for most adults. And then almost all of the studies show that actually probably 1,000 micrograms is the optimal for insulin resistance, because the 1,000 micrograms typically always beats out the 200, but at least 200 to help out insulin resistance. So there's a huge discrepancy between 30 micrograms to prevent deficiency and 1,000 for improving insulin resistance.
Yeah, and there's also the thing that what's normal isn't definitely not optimal. So like, if you look around you, then most people are like considered normal, that they are somewhat metabolically inflexible, they somewhat have metabolic syndrome, insulin resistance, obesity, those things. So if you want to be normal, then yeah, keep doing what you're doing. So there's a huge difference of what it means actually to be optimal and healthy.
Right, and well, the other thing is that people shouldn't get confused that you can just start taking supplements and boosting your mineral status and that's going to fix everything, because you need to be insulin sensitive to even utilize a lot of your minerals in the first place. So you could be taking a lot of magnesium, potassium, but if you're insulin resistant, you can't drive it into the cell for it to work well, and you'll start kicking it out in the urine too. So really the first step is to try to fix, eliminate the harmful substances that are causing you to be insulin resistant in the first place. That's automatically going to boost your mineral status because you're going to be able to utilize those minerals better.
Yeah, it's always somewhat easier to take away the bad things than the requirement for like adding new things also drops a lot, and it's just easier.
Right.
Maybe let's talk a little bit then about some specific minerals. For example, like, magnesium and calcium, those are one of the kind of, like, there are different minerals that kind of work in pairs and kind of contribute to each other. So magnesium and calcium are like one of them.
Right. And I think, calcium's sort of gotten a bad rap recently. And that's primarily though because we're taking calcium and getting it through supplements, and you're spiking blood calcium levels because people are taking 500 to 600 milligrams all at once, and it's sort of unnatural. But getting calcium through the diet is extremely important, and it's one of the most common nutrient deficiencies. But the problem is you can't just throw a calcium capsule at someone and say, okay, you're all set now. It doesn't really work like that. So really calcium should be coming, if you tolerate them, through things like either natural mineral waters or dark greens. Or even, just because a lot of animal foods aren't very high, but you can get some decent calcium though too from like pastured milk or pastured cheeses too. Those are great sources of calcium because they're more bioavailable actually than calcium from vegetables. So, I think, calcium, I get most of my calcium through mineral waters actually. So because that actually helps bring other minerals too, like magnesium, that a lot of people are deficient in.
Yeah. And like calcium and magnesium both are important for the bones and the cardiovascular system. So yeah, if you're like, there are some association between high calcium supplementation and this calcification and atherosclerosis because of the same reason that you mentioned. You get this massive dose of calcium, whereas that association does not apply to dietary calcium. So dietary calcium is actually the opposite effect of that, and you need to get your like calcium primarily from like whole food sources. And dairy products are good for that, and the leafy greens, as well as like bones, bones of sardines, for example. If you eat the sardines, then you can eat the bones and get some calcium from that as well.
Right. The one key, that's true. Yep. And then we did have a nice figure showing that about 450 milligrams of magnesium was associated with the lowest coronary artery calcium score, the CAC.
Yeah.
And also calcification in the aorta too. 450 was, they didn't measure. I think people just didn't in the diet consume more, but I bet you if they had 500, 550, because it would be even less. And we even had a couple of references showing that 600 to 700 milligrams of magnesium, I think, was associated with even the lowest risk of diabetes and insulin resistance. So that's sort of why we sort of have this optimal range between 400 and 600 in the book. But yeah, there's this balance between calcium and magnesium, and a lot of people are just deficient in both through the diet. So the one key thing here is that oxalates make calcium not very bioavailable. So I consume spinach for the magnesium and the potassium, but a lot of people think it's a good source of calcium and iron, but it's not. So the oxalates make it a low source of bioavailable calcium, and because it's non-heme iron, it's only 2% bioavailable unless you're consuming it with things like vitamin C, or if you add meat to it. For some reason, adding meat to non-heme iron increases its absorption, but you don't want to just rely on greens for like iron bioavailability.
Yeah, and there are some other, like the phytates and like phytonutrients can also decrease calcium absorption.
Right.
And I believe it's a coffee but in some studies it was shown that not per se like just the coffee and the phytates in the coffee, but also the caffeine itself, like the stress response, can make you excrete some calcium.
Right. I mean, that's a good point too. And we cover this in the book as well, that stress can cause magnesium deficiency, because literally when you start releasing more cortisol, you start releasing more noradrenaline, you start pushing magnesium out in the urine. So everyone being super stressed in this type of environment too is just kind of taxing their magnesium status.
Yeah. So some people are like at a higher risk of the calcium deficiency and let's say the osteoporosis that can result from that. Like women with menopause usually tend to be more like at a risk of this osteoporosis because of the menopause promotes like calcium excretion, estrogen and things.
Yeah, the drop in estrogen. Yep, exactly. Their calcium balance goes down. So it doesn't, coffee seems to be, you always want to consume organic coffee, but coffee can get people into trouble if they're postmenopausal and they're not having enough calcium in the diet, because it does push out some calcium in the urine. And if you're not matching that, that's one mineral that calcium can cause certain people to potentially become depleted in.
Yeah, and what about magnesium?
Not a whole. If the dose is causing you to have a lot of diarrhea, it can, because there's a decent sort of like, in the bile, you have this like sort of like reabsorption, recycling of a lot of magnesium and calcium. So diarrhea can definitely cause deficiencies in both. So what I've kind of switched over to is I found my own personal optimal intake for coffee, and that seems to be about a half of a cup of coffee, maybe a little bit higher, maybe 60 to 70% than a full cup. And I've noticed that by going down by taking the caffeine down from like 100 milligrams to maybe 50, I don't get the caffeine blues anymore. So I can do like a half a cup 2 to 3 times a day, and it seems to keep me nice and activated and focused, but then I don't get those caffeine blues.
Yeah. I also tend to do best if I do like only 1 cup of coffee or something a day, and that's where you avoid all these negative side effects from it, and you prevent the dependency of it either. Like you don't become like that you need to have the coffee to wake up.
Right. So what happens is people are over consuming it. So it's sort of like this, just like with sugar, when you start increasing like a super physiological spike, then there's like this depletion in the body where now that's like the caffeine blues, where your brain's not functioning as well. So if you can keep the spikes less, then the troughs will be less. And so you'll be more stable throughout the day.
Yeah. But at the same time, like coffee can also be good for things like preventing iron overload, which is I think one of the best kind of compounds or substances for preventing excess iron.
Yeah, it's great. It's great to consume if you're like a heavy meat eater, or you're someone who has like hemochromatosis, or someone who's dealing with like, iron overload. Coffee is great to pair with animal foods, not just from the binding of the free iron, but reducing some of the oxidative stress products that come from eating cooked animal foods.
Yeah, and iron deficiency, or like, there's this like misconception as well as like a controversy about iron in relation to anemia, because anemia is like a very widespread medical problem across the entire world, but usually people treat it with like adding additional iron, but as we talk about in the book, that's not really, hasn't been shown to be like that effective, and it's not actually the root cause of the issue.
Right. There's been a lot of studies showing that just giving iron supplements to people with quote unquote iron deficiency doesn't help a lot of them. It can if the true deficiency is due to iron, but taking it as a supplement too leads to more oxidative stress as well. And it's really not the best way to treat iron deficiency anemia. You really want to get it from food if you can. And there is this misconception that if you're iron deficient anemia is due to low iron intake, because it makes sense, but it can also be due to the inability of your body to get sort of iron onto transferrin and move iron around in the body. And in order to sort of change iron from the form that gets onto transferrin, you need good copper status, because that is important for moving, and even getting iron out of the liver, exporting it out of the liver requires copper. And a lot of people are deficient in copper simply because most foods that are consumed in the United States don't have a lot of copper in them.
Yeah, so copper is more of like helps, or like it promotes the actual active form of hemoglobin, basically, that I believe it's a ceruloplasmin is the enzyme that is copper dependent, and that is kind of helps to activate hemoglobin, which then leads to the proper oxygenation of the tissues that is not present in anemia.
Right. Copper to iron is sort of like magnesium to vitamin D, right? Like magnesium activates vitamin D to the active form, and it helps vitamin D actually move around the body. And that's kind of exactly what copper does with iron.
Mm-hmm. Yeah. And what would be like a ways of getting this optimal amount of copper and iron as well?
Probably the best way would be to pair muscle meat with the liver. That's probably the best way to do it. You can also get good amounts of copper in oysters, but oysters are also very, very high in zinc. And a lot of oysters have contamination with cadmium. So you got to be careful how much. You probably don't want to consume more than 2 ounces of oysters per day. But obviously it depends on where they're being sourced from. But one of the highest foods that kept coming up in our book of minerals was mussels. Like mussels are so high in manganese and copper. It's actually second only to liver is the highest food source for copper. And I myself kind of like suffer from not picking mussels. Like I just don't include it in my diet, but I probably should, because just a couple ounces of mussels is going to boost chromium and boost manganese and copper. And those really are the minerals that a lot of people are deficient in.
Yeah, mussels and seafood is very high in a lot of the minerals, but I believe it's also like very dependent of the source and like the particular amount of those minerals in the sea or in the like soil for that matter. So yeah, that matters a lot on their like region. And if you're like getting like farmed seafood, then those minerals are probably not there in the adequate amounts.
Right. True.
Yeah. What about liver? Like liver is like one of the most nutrient dense foods, but like too much liver is probably also not good because of getting like maybe too much copper and other nutrients.
Right. I think the perfect amount is between 1/2 to 1 ounce of liver per day. That's going to help give you vitamin A, folate, and it's also going to help you give you copper, which those 3 nutrients are very deficient in most diets. And when you pair that with, most people should be consuming probably about 12 ounces of pastured red muscle meat for the B12, the protein, the zinc, and the iron. And then women need more than twice the amount of iron than men. So women need 18 milligrams to hit the RDA for iron. Men only need 8. So very important for women to get animal sources of iron, because it's 10 times more bioavailable than plant sources.
But what if you don't eat that much meat? Like, what is a plant-based source?
Well, you got to make sure you're combining vitamin C with things like beans, in spinach and in other greens that are somewhat higher in iron to try to make it more bioavailable. If you don't eat a lot of animal foods, try to have your portions of meat with those plant sources, because the heme iron, and when you eat meat, it boosts the bioavailability of non-heme iron.
Yeah, that's a good tip. Like, yeah, I do believe like there's a whole lot of you can achieve with just like 1 single ounce of liver. So even if you are like on a very plant-based diet, just eating 1 ounce of liver can go a whole, it can do a lot of wonders for your nutrient intake.
Exactly. Yeah. If you're smart and you select certain organs, and for someone who's primarily wants to be plant-based, it does go a long way. But I still feel that most people would be optimal if they consumed a minimal of 10 to 12 ounces of red muscle meat.
Per week or per day or?
Per day. Per
Okay.
day. Otherwise, it's going to be very difficult for you to hit your RDAs for protein, iron, zinc, and B12 too. And so, if you're not doing that, then all of a sudden you got to be taking B12 injections or supplementing sublingual B12. And it's just, you're sort of piecemealing what you could get from real food.
Yeah, for sure. But what about the frequency of eating those foods and getting like those minerals? So like, it's probably not a good idea to like have this massive spike in those nutrients and like not get any on for the like the rest of the week. So how would you like spread it out across the entire week?
Right. So that's why I don't like people consuming very large amounts of liver all at once, like once a week. So instead of consuming like 7 ounces of liver once a week, I think it's better to do like a ½ ounce to 1 ounce every single day if you can, or maybe 1 to 2, 3 times a week. That's a better way to do it. And typically I have it at least, I probably consume 1 to 1.5 pounds of pastured meat. But that is also coming from things like liver too and heart, because I consume muscle meat with blend. I get them as blends because most people hate the taste of liver. And so if you can buy blends from companies that are already like 75% muscle meat, 25% heart and liver, you can get those from places like White Oaks Pasture, North Star Bison, Force of Nature meat. And then if it's still too much for you, you can just add more ground beef to that. And you can either make like taco meat, or you can actually just grill them as burgers and you barely taste the liver. Mm-hmm. And then I'd like to add to that on top of that. So animal food, you have to balance, most people should be balancing animal foods with what I call alkaline minerals, because what ends up happening is when you consume animal protein, the liver oxidizes the sulfur-containing amino acids, methionine and cysteine, to sulfuric acid, okay? And then bicarbonate has to take care of 2 of the hydrogens, and then you're left with this negatively charged sulfate. And in order to eliminate that, if you don't have good amounts of alkaline minerals like potassium and magnesium, the body has to produce ammonia to get rid of that sulfate because it has to maintain electroneutrality. So sulfate is negatively charged. It takes ammonium to excrete that. So if you're not getting these alkaline minerals, which could actually bind to the negatively charged sulfate, your body has to produce a lot of ammonia, which can damage the kidney. So there should always be this balance between animal foods and some type of alkaline minerals, either from plant foods or like bicarbonate natural mineral waters to balance out the acid from animal foods.
Yeah, and that acidity will also promote like the excretion of calcium and magnesium maybe.
It absolutely can. And so we didn't know this until the 60s when we did balance studies on people. And a lot of people don't believe in this because our bodies have this buffering system where it's very difficult to change the pH of the blood. So the body will maintain a really good pH for a long time, but your bicarbonate could be in the tank. You could be stripping muscle, bone, connective tissue. You could be producing massive amounts of ammonia, and your urine could be very, very low pH, which is indicating that you have low stage chronic metabolic acidosis. And so getting the alkaline minerals is super important for balancing out the acid.
Mm-hmm. Yeah. And I believe like bicarbonate waters can also do the trick so that you get this also alkaline effect from that.
Right. So I drink Gerolsteiner, but there's many other natural mineral waters that contain bicarbonate. And I get this question all the time. People say, well, won't the bicarbonate affect the stomach pH? And not really, because it's a very low dose, but you're consuming it throughout the entire day. So it adds up over the weeks. And so it's completely different than taking like a sodium bicarbonate tablet.
Right.
So for example, people take like 20 grams of sodium bicarbonate before like their athletic performance. Gerolsteiner only contains 1.8 grams per liter. So it's a very low, slow infusion, and it's already contained in fluid. And we absorb water very quickly within 15 minutes. So it's not going to like sit in the stomach for hours, sort of like, combining with the hydrogen and forming carbon dioxide.
Mm-hmm.
It's not going to suppress the acid very long. So if you are worried about the whole changing the pH of the stomach, what you can do is not drink a whole lot of bicarbonate mineral waters like within 1 to 2 hours after eating, if you're truly worried about affecting the pH of the stomach. But again, unless you're consuming large amounts, you're really not going to affect the pH of the stomach that much.
Yeah, that's good. Good advice there, and it's a way like if you get it throughout the entire day, then your body absorbs that bicarbonate and kind of stores it away into the basically storage bank for the bicarbonate, and then when it needs to like buffer the acidity, then you have like a larger storage of that to pull from. Whereas if you take like a sodium bicarbonate before a meal, then some of that bicarbonate will affect your stomach acid and can cause like heartburn or indigestion as a result of that. So spreading it out is the way to go, because then your body's able to deal with it better and kind of use it more efficiently.
Right. And a lot of carnivores are probably suffering from chronic metabolic acidosis. So I've asked some of them, what's your bicarbonate level? And even the high quality carnivores, their bicarbonate levels are around 23, which is not optimal. That's essentially the bicarbonate level of a 60-year-old. You want bicarbonate to be like 25, 26, 27. And before athletic performance, you want it to be above 30. It's called peak alkalosis, to sort of protect the body from the acidosis that occurs. So it's pretty simple to look for. If you have acidosis, you just have to know what to look for. You'll have low urinary citrate, you'll have high ammonium in the urine, and you'll have low bicarbonate. Now, technically, low bicarbonate, most people say it's not low unless it's lower than 23. But really, from a low-grade acidosis standpoint, anything like 24 or lower is highly suggestive that you have too much acid in the body.
Yeah. So would it be like a good to take, or like if you have like bicarbonate water, to drink it like during the fasted state as well, because you are more acidic while fasting and not having eaten?
100%. So by day 2 of a fast, that's like a complete fast, you're in a state of mild chronic acidosis. The bicarb level drops. Even the pH is right on the borderline of, typically what we call it acidosis, but really it's acidemia. It's higher acid in the blood. So the pH is teetering around 7.35, which is just borderline, but you're definitely in metabolic acidosis. And the reason is because the keto acids are acidic. So you're in this chronic state of higher ketone levels, which are acidic, and it's putting you in a state of acidosis. So the magnesium loss that occurs with prolonged fasting and the calcium loss that occurs with prolonged fasting in the urine is due to the metabolic acidosis. It's pulling it from bone because you're not eating any, but you're spilling 100 to 150 milligrams of magnesium for the first 5 days of fasting. So where is that magnesium coming from? It's coming from bone due to the metabolic acidosis. So if you just took natural mineral waters with bicarbonate to offset the acidosis, plus they're providing calcium and magnesium, you're going to prevent most of the harms and reap all of the benefits.
Yeah, and mineral waters are generally also a very good way to get the minerals, and because the absorption is higher, and like we show in the book that or the studies show that drinking the mineral water alongside with your meal actually increases the absorption of the minerals from that meal, while at the same time lowering like postprandial blood sugar and postprandial hyperlipidemia. So it's a very one of the best like just drinks or beverages to just include. It's quite amazing actually what we found out from the book.
It is, and we cite another study too that drinking 7 ounces of mineral water 7 times a day, that slow infusion, increases magnesium absorption and retention by 40% versus consuming large amounts like 20, 24 ounces twice a day. So it's that slow infusion, which mimics more of an evolutionary intake. You would have just drank water throughout the day, and it would have been natural. It wouldn't be these artificially softened waters. It would have been natural waters that contain bicarbonate, that contain magnesium, that contain calcium. So it's something that I do, but you can get bicarbonate by consuming fruits and vegetables too. So if you just like berries, you can get it because the citrate will convert to bicarbonate. The malate, the gluconate that are in vegetables is what actually converts to the bicarbonate. So a lot of people sort of think that it's the magnesium, the potassium, that is sort of the alkaline part of it. And it is and it isn't. It's really the anions, negatively charged anions, that are turning into bicarbonate, and the positively charged cations are combining with sulfate, preventing the body from forming ammonia, which is toxic to the kidneys.
Yeah, yeah. So what would be like some of the kind of best brands for the mineral waters that you maybe use and what you know?
I would say Gerolsteiner is good. That's the one I use. Magnesia is really good too. It's actually higher in magnesium, but lower in bicarbonate. So if you're someone who just doesn't get a lot of magnesium in the diet, and I'll tell you what, like there's some tests too that you can test your urinary magnesium to see if you're deficient. I bet you a lot of people would be pretty shocked at how low their magnesium in the urine is, which typically indicates you're holding on to magnesium. So the waters, like you said, are the most bioavailable way to get magnesium and calcium. And most people think like dairy and milk is the best way because it is a very bioavailable way, but mineral waters are just as good. They both have about a 34% bioavailability. So San Pellegrino's okay. It's not as high in magnesium. It's more higher in calcium, and it has, I think, a little more sulfur. So you have to match the sulfate content of waters. You gotta be a little bit careful because that sort of creates, that leads to more of the acid load coming out in the urine. So you just got to match it with fruits, vegetables, bicarbonate.
Yeah. Yeah. And the book has like a graph for like the top mineral waters from both North America and Europe. So like there's maybe like 40 or 50 of the biggest brands and their content. But maybe let's talk about some of the less known like minerals that are not necessarily considered like essential by the authorities, but they are still like really important, and like there are some serious consequences to being deficient, like maybe boron. Let's start with boron.
Yeah, boron's probably the best example because there's studies in humans showing that if you consume about 3 milligrams, you're improving testosterone, you're improving bone health, you're reducing bone loss. And so we don't even know the true optimal intake. Is it 3 milligrams? Is it 5? Is it 10? Who knows? But the upper limit is around 20 to 28 milligrams. So you have a fairly large range you can go to. The problem is nobody's consuming boron because the foods that are high in boron are typically restricted in our diets. Mm-hmm. So the highest sources are things like raisins, peaches, dates, black currants, and avocados. So for most keto carnivore people, like those foods are like off limit, right? So but a little bit of raisins can go a long way because they're so high in boron. So,
yeah,
if you work out, you're lean, you have muscle, you don't have to worry about like, half ounce of raisins.
Yeah. And prunes as well. Like these dried fruit tend to be really high. But yeah, like you mentioned the 3 milligrams seems to be, kind of good optimal, at least intake. But yeah, like most people in the West tend to get only like 1 milligram or, around 1 to 2 milligrams. So it's definitely an example where the kind of average intake is definitely not really meeting the kind of requirements because there's no like specific RDA for for boron, and like the World Health Organization recommends you get like at least 1 milligram, which is considered maybe like the minimal, like bare minimal for just the survival.
Yeah, and I admit to my diet isn't perfect in getting boron, and so I do take probably twice a week a trace mineral supplement that gives me boron, chromium, and molybdenum. So those like quote unquote non-essential sort of the overlooked minerals, let's call them.
Mm-hmm. Yeah. Chromium as well is another example of that it has been shown to be good and beneficial for like diabetes and insulin resistance, but it's not there isn't like a specific RDA for it.
Right. And And really, the only real good source of chromium is mussels. I mean, some seafood like lobster, crab, and shrimp are pretty good too. But who's eating lobster tails and crab every day? You know, it's expensive. I mean, some people might eat some shrimp every day, but shrimp is still not super high in chromium. I think 3 ounces of shrimp will give you around 22 micrograms of chromium, whereas that same amount of mussels would give you like 120 micrograms of chromium. So your top 5 foods in chromium are essentially not consumed in the United States. And then you have broccoli, that's the next step below that, which is maybe 20 micrograms of chromium per 3 ounces, which is, you know, you want probably 100 micrograms of chromium per day, optimally. And we lose a lot of chromium through sweat, not on a quantitative level. You know, the studies show you might lose 7.5 micrograms per hour of exercise. That might sound like not a lot, but we only absorb 1% of our dietary or supplemental chromium. So in order to replace 7 microgram loss in sweat, you have to consume 700 micrograms. So if you're someone constantly hitting the sauna, you're someone who lives in a hot environment, or sweating a lot or exercising a lot, you probably need a chromium supplement.
Yeah, and the chromium is used, like, let's say, bodybuilders and the fitness people as a like a glucose disposal agent. It's quite known for that. It's one of the main ones, maybe next to like berberine or something. And yeah, it does have like a bigger effect the higher your blood sugar is. So yeah, if you're like, you know, let's say if you're like insulin resistant, you're diabetic, or you're like ate a high carb meal, then the chromium would help you to essentially enhances the action of insulin and helps you to clear the bloodstream faster from the blood sugar, so you get like less of the negative side effects from that hyperglycemia. So yeah, like you know, even healthy people can benefit from it. It just depends on the situation. Like you may not need to take like a chromium supplement if you're eating like a low carb diet, but if you're like eating a high carb meal, or you're like, yeah, you're exercising a lot, sweating a lot, then you probably do need to like maybe eat, let's say, like more mussels, or just take a supplement.
Right. I think so. There's 2 factors. So exercise seems to sort of liberate chromium because it's needed to help just enzymatic function, right? And that goes up with exercise. And then you lose it in the urine. So exercise doubles urinary chromium losses. And then when you, like you were saying, when you consume a high carbohydrate meal, it liberates the chromium from the cell, and then you lose it. It's like the body doesn't have this great way of like retaining chromium once it's released to be utilized. So you triple your urinary loss for chromium when you consume a high carb meal. And so if you're constantly eating high carb meals, you're exercising a lot, so you're losing the chromium through not only the urine when you exercise, but also through sweat. And because the bioavailability is so low for chromium, it's just that 7 micrograms will be a killer to your chromium status if you keep doing that over the long run.
Yeah.
And we talk about the top like 5 minerals that are lost in sweat in the book. And we have a nice table of exactly how many micrograms or milligrams are lost. And we sort of list it in a hierarchy of importance. So you have your obviously salt loss, which is sodium and chloride, but you also lose copper, iodine, selenium, and then the chromium. And really copper is a huge one that is lost through sweat because, again, dietary copper has a fairly low bioavailability, only about 33%. And most people are only consuming 0.9 milligrams of copper per day, but they're losing 0.4 milligrams through sweat. And in order to absorb 0.4 milligrams, you've got to actually consume more than 0.9. This is only about 33% bioavailable. So if you're sweating an hour a day and losing 0.4 milligrams of copper, and you're only eating 0.9, you've actually lost more copper than you've taken in, and you're slowly going to become depleted. So salt is super important, chromium is very important, but also copper, and then selenium and iodine too get lost in fairly large amounts.
Yeah. And the last one you mentioned was molybdenum. So what's the role of molybdenum?
Molybdenum helps us sort of detoxify sulfites. They formed in the manufacturing process of like wine. And so it helps us detoxify that. So if you're consuming a lot of sulfites, you're sort of like depleting your molybdenum status. And, molybdenum, really the only good source of molybdenum is liver, which kind of takes us back to why molybdenum actually falls in the 10 minerals that most people are deficient in, because liver is really the only very good source of it.
Yeah, and molybdenum is also for fixating nitrogen, which is, basically, just your body tissue and protein, and as well as like detoxifying the ammonia that we produce. And like also in addition to liver, there's also beans. That was a surprising high in molybdenum. Like this is different, black eyed beans, lentils. That's a thing.
Black-eyed peas. Yeah.
Yeah. Yeah. Are there anything else that you want to cover about the book? Like anything we didn't, or like something that people would specifically need to know?
I think we hit a lot of the important points. I think what people should know is that a ton of research and effort went into this book. It's something I'm sure you're proud of. I'm super proud of it. And if you want to know the optimal levels for all of the 17 minerals that we talk about, this book is for you.
Yeah. I think it's you're probably not gonna absorb all the information in like one go or one read. Like it's probably something that you'll kind of probably have to reach back at the bookshelf for like several times and get some cool insights from there. Like what are the best foods for some mineral, and what are the symptoms of maybe being deficient, and what kind of tests you need to do, and that sort of thing. So it's very, very in depth, and I do really enjoyed writing it, as well as researching, and learned a lot new things as well.
Yeah, I think you're right. We didn't even mention that we cover the best ways to test for many of the minerals. We cover every single chapter that has a mineral. We cover all the foods in highest level to lowest level, so people can understand which foods to select. So I think it's a great balance of science, but like what people can really do to help their own health out.
Yeah, absolutely. Well, yeah, where can people get it? Where can people get the book?
Yeah, Amazon is where the book is available, and then the Kindle will probably be out in a couple weeks.
Yeah, awesome. And yeah, where can people learn more about you or follow you?
So my website is drjamesdinick.com, and I'm pretty active on Instagram and Twitter at drjamesdinick, DINIC.
Awesome. Well, we'll put all the links in the show notes, and yeah, it was a good show.
Yeah. Good talking to you, Steve.
Yeah, you too. Bye.